Okay, looking at number 43 here, we've got y prime is equal to tangent of y. A little bit weird because there's only really one factor, I guess you'd call it here, the tangent of y, and it's over there on the right-hand side. So here's what we're going to do. We're going to remember that y prime is dy dx. We are going to divide both sides by tangent of y to get a 1 over tangent of y on the left with a dy, and then we'll multiply the dx from the dy over dx over here to the right-hand side. And it doesn't look like much, you guys, but that is our separation of variables. Normally at this point, I'd go ahead and draw those red integral signs, but I tell you what, we're going to do one other thing here first. Integrating 1 over tangent of y probably doesn't sound like a whole lot of fun, so I'll just remind everybody that 1 over tangent of y is cotangent of y. Okay, and if we remember that tangent is sine over cosine of y, then its reciprocal is going to be the cosine of y divided by the sine of y. dy equals dx. Okay, so a little bit of gymnastics right there mentally to get to this spot. We divided by tangent to get 1 over tangent. Mentally, we converted that into cotangent, and then remember that cotangent of an angle is cosine of that same angle divided by sine of the same angle. And now, I think we're ready to go ahead and anti-differentiate both sides. But what might be troubling you about problem number 43 is that integrating cosine of y over sine of y is a little bit of a pain, and that, you guys, requires some work. That is going to require u substitution. We're going to let u come from the denominator of this fraction, sine of y, and then take the derivative of u to be cosine of y dy, which is exactly everything that's left over. So where am I here, guys? I'm still not ready to evaluate the integral yet, although I will be in a second. And this now becomes, let's see, the sine of y on the bottom is a 1 over u, got it, and then the cosine y dy, ooh, that was ugly, is a du, not a dy. Nope, I did it again. U equals, and for now, that right side is still just going to be the antiderivative of dx. Okay, so now that we've got that, let's go ahead and evaluate this. That left side is going to become the natural log of the absolute value of u, and let me just go ahead and replace the u now with a sine of y and save myself a step there. The right side, the antiderivative, remember guys, your integrand here is 1. The antiderivative of 1 with respect to x is x, and there's a plus c at the end of all that. Now, I'm looking at the initial condition right here, guys. Ooh, that didn't all get lumped together. And I'm trying to determine right here if I think it's a better idea to try to find C right now or to try to come up with C later. I don't think it's going to be too bad, and I almost always do it right now, so let me go ahead and try that. When x is the natural log of 2, y will be pi over 2. Natural log times, or natural log of, I should say, let's think about this. Sine of pi over 2 is your y value, which is going to be 1. And the absolute value of 1 is 1. So there's your left side. It equals x, which is the natural log of 2 plus c. Well, what I'm hoping you guys remember, though, is that the natural log of 1 is just 0. That's asking you the question, e raised to what power is equal to 1, and so that whole side just becomes 0. So I guess that means that c, as I have found it right here, is the opposite of the natural log of 2. Okay, not the prettiest constant value we've ever come across, but sometimes life is ugly. Okay, so back to where we were a moment ago, guys. Switch back to blue, and let's go get them. The natural log of the absolute value of the sine of y is going to equal x minus the natural log of 2. We're going to get rid of this natural log on the left by exponentiating both sides, and we're going to get the absolute value of sine of y. I'll just write that as sine of y and then put a plus or minus over here on the other side. Now, e to this binomial power becomes e to this power multiplied by e to this power. And the e to the negative natural log of 2. All right, guys, I better write that out because that's going to get a little bit messier than I thought. This is e to the x, and then, actually, it's getting divided by, no, let's not do that. It's going to be e to the x, okay, and then, okay, so then plus Nope, take that back. Times e to the negative natural log of 2. Now I would use the power property for logarithms and bring that negative there to make it 2 to the negative first. So that now is going to become natural log of 1/2. The e and the natural log cancel, and the 1/2 I'm going to bring out in front of this. So that's going to be a 1/2 e to the x power there on that right-hand side. Yeah, that's what's going on here. I'll have to figure out eventually whether it's plus or minus, but that's where we're at right now. And now the weird part. Boy, we haven't seen this, I don't think, in any problem that I've done with you guys so far. To get y by itself, we have to do an inverse sine. So it's going to be y is equal to the inverse sine of the entire right-hand side, which is either plus or minus. I'll have to figure that out. 1/2 e to the x. So the question is then, guys, is it the plus or minus case that will get this initial condition to work out? So as I'm looking at it, I think it's going to, well, I shouldn't say that. Never mind, let's just dive into it. When x is natural log of 2, that goes right here. So this becomes a 1/2, and then e to the natural log of 2. Well, the e and the natural log cancel, and the 2 just comes down and multiplies by that 1/2 to make 1. So now we're taking the inverse sine of either plus or minus 1, and we want to end up with a final result here of pi over 2. So the question is, guys, is it the inverse sine of positive 1 or the inverse sine of negative 1 that's going to get us pi over 2? Well, if you think about your unit circle, guys, they're already telling you where to look. Pi over 2 is this angle right here, and its sine value up at 12 o'clock there is positive 1. So no more plus or minus right there. In fact, I should get rid of it here, and that's just going to be a positive. So actually, that's my answer right there, guys. Y is equal to the inverse sine of 1/2 e to the x. And that's our solution then, everybody, to problem number 43.